Hey everyone, critical thinking. Hey, you you have a problem today, or just chilling out? Okay. I don't see anything from you critical, so if you do have a problem, please let me know. If not, I think I'll go right over to studying from this book. Because having to get questions off the internet is kind of lame. Okay. I do kind of want to quickly review the stuff that I already went over like last week or 2 weeks ago. I don't remember how long ago, but like just like quickly over like the properties that we have at our disposal here for integers. So the ordering principle, every non-empty set of positive integers contains the smallest member, which I think, oh, the music change kind of weirded me out. Which I think would also imply that there's a biggest member too, because you could kind of like continuously chop off the smallest member until you get just one member. You can call that your maximum. We have the division algorithm, which is you divide two integers and you fix b to be positive. Interesting. It's not really, if one is negative and one is positive, it doesn't really make a difference which one is negative or positive, because you always multiply by -1 over -1. But I think for the algorithm, you probably do care that you probably do care about which one is positive and which one is negative. So we take b as positive, I guess. Since unique integers q and r with the property that a equals bq plus r, where r is between 0 inclusive and b non-inclusive. And we define greatest common divisor and relatively prime integers. And if their GCD is 1, then they're relatively prime, okay? GCD is a linear combination, right? And that's what I was getting stuck on the last time I was looking at this, because I couldn't figure out how to express the GCD of 7 and 11 as a linear combination, because I just was too exhausted to do mental math, I guess. No, it was really not that hard. And it's just extending the definition of relatively prime to include this linear combination thing. But, you know, if it's a linear combination, you can also read that as GCD of a, b equals 1. So it doesn't seem like a leap. Probably zoom in on this, right? Forgot about that. Then Euclid's lemma, if p is a prime that divides a, b, then p divides a or p divides b. Makes sense. We have the fundamental theorem of arithmetic. Every integer greater than 1 is a prime or a product of primes. Product is unique except for the order in which the factors appear. Right. It seems like a very wordy way of saying things, but I assume it's for a reason. I guess because they're talking about whether the order matters or not, which might... I mean, in normal arithmetic, you know, things are commutative. Which I guess they're still using here with the renumbering stuff, so I'm not sure what they're on about with all this, I guess. But I'm sure there's just a reason that I'm just not aware of. We have the least common multiple being defined. Then we get into modular arithmetic, which I was about to skip over this, but I should actually just refresh myself on breaking it out into this like un plus r form. So yeah, if you have a mod n, then the result of the mod is going to be r. So you have 3 mod 2, you say 3 is equal to 2 times 1, then the remainder is 1, so your result is 1. If you have a negative number, you have to go past -2 because r must be positive. So if you have -2 mod 15, you would take a -1 times 15, which will get you -15. And of course, the remainder there is 13 between -15 and -2. If your first number is smaller than the second number, like you have a fraction less than 1, your mod is always whatever the first number is, because you multiply the bigger number by 0 there. So yeah, I've read through this up to and including mathematical induction here, which I feel pretty decent about. Induction, well, strong induction I'd never done before. Spectrate. Dude, the competition for first, like, people aren't going after as much as they used to. Apparently. Skipping over all this equivalence classes and function stuff for now. So yeah, I just left off on number 4. Can't say that you're in a lol game? Oh, okay, well, good luck with your lolling. Sure that S and T are not unique. So kind of like the first thing that we should think of for S and T that I didn't think of last time I looked at this problem is that S is going to be +3 and T is going to be -2. So you get 22 minus, nope, I had that backwards. S is a -3 and T is +2. So you get -21 plus 22 equals 1. And then I think you can scale both those numbers by any integer you want, and it's also true. So we could say that instead of -3, let's multiply it by 2 and say -6. And 4? Does that work? I don't feel like that works. Oh, no, it's not quite that simple. Yanis kind of gave me how you figure that out the last time I streamed. So let's actually remember that. You have 1 equals 7 times s plus 11 times t. Then you can say that 1 is equal to 7 times -3, we said, plus 11 times 2. So it's not as simple as, I mean, you do start by multiplying everything through by a number. It's not so easy to just multiply everything by 2 though. You multiply everything through by 8 because 8 has a nice property of being equal to 7 plus 1. The 1 is going to match there, and the 7 is going to match there. So let's multiply each side of the equation through by 8. And I'm going to multiply the 8 into those like s and t multiples, I think. And then now we get our nice property that 8 is 7 plus 1. Let's subtract the 7 over here, and then we're going to be able to do some grouping, is the idea. And now we've gone back to this nice like 1 equals thing that we want. So I'm going to factor the 7 out and say that -24 minus 1 is -25. And let's try and do some mental math to verify this. 7 times -25 is -175, right? Yeah. And 11 times 16, oh, that's 176. Okay, that's kind of nice right there. Now, I am curious if instead of doing 8 equals 7 plus 1, can we say 12 equals 11 plus 1 and multiply everything by 12? So I want to try the other way too. I'm sure it works, but let's actually like demonstrate it. Hey, Jed. The question, so I'm doing, let me back up and explain it. So for the abstract reading group that Penn Center is doing, we're working, since there's no one in chat asking a question, I'm kind of like trying to catch up on it, but I'm probably just going to be super behind. But the question is number 4. This is like for the preliminaries for abstract algebra, so we're not actually into groups or rings or anything like that. What we're doing right so far is just working with integers and like modular arithmetic and things like that. And so yeah, we just have to find integers s and t such that 1 is equal to 7 times s plus 11 times t, which is like saying the greatest common divisor of 7 and 11 is 1. And then you have to show that s and t are not unique, which Yanis showed me how to do last time I streamed, and I was just kind of like working through it for myself so I can understand it. Right. That's the kind of like easiest combination to come up with. And then we have to show that they're not unique, so we need to come up with at least one other, which I just did. S equals -25, t equals 16. And I want to come up with a third one. So let me, I'll kind of like backtrack and show you how you can generate more combinations using your first one. So if you're able to like, you know, do guessing checking to find -3 and 2, you can multiply both sides of this equation through by 8. And we choose 8 in particular because it's equal to 7 plus 1, which will come in handy down here. So what I did here is I multiplied everything here through by 8, and I multiplied the 8 into the -3 and the 8 into the 2. So we have 8 equals 7 times -24 plus 11 times 16. And then we say that 8 is equal to 7 plus 1. And then we subtract that 7 over and we factor it out. So that's how we get our next kind of a linear combination possible pair. And I want to try the same thing, but then with 12 instead, because it's 11 plus 1, just to, you know, confirm that it works. I assume we're gonna get that negative 14.9 thing next. Let's try it though. So if 12 is equal to 11 plus 1, let's multiply that through by 12. Actually, no, I don't think we're going to get the next thing they just said. Negative 36. 11 times 24. Now we'll say that's 1 equals to 7 times minus 36. Plus 11 times 24 minus 11. So then 1 is 7 times negative 36 plus 11. That's 24 minus 1 is 23. And how does that math? That's a little bit harder to do mentally, isn't it? 7 times 36. 72 times 3 is, come on. I know I can do this. 72 times 3, 6, 42, 456? No, that's way too high. 72 times 3, 256. No, I shouldn't do this mentally. I need to add another 36 onto that after. Let's not get worked up over freaking mental math. 7 times minus 36 plus 11 times 23. 1. All right, I did it right. The math does check out. But let's check out your combination, Jed. I wonder if we can check that somehow, because it's lower than the one that I got. Yep, that also works. Hey, Yanis. Nothing much. I was just trying out the thing you showed me last math stream with this problem 4 and generating new cases for S and T. So I tried it both the way that you said with multiplying through by 8, and then I also just I tried multiplying through by 12 as well, just confirm that way works too. So thank you for that. S is equal to 11, or negative 3 minus 11n. T is equal to 2 plus 6n. Oh, yeah, you introduced a third thing. How do you get those forms with n? I'm trying to work it out. Scott, your analysis exam graded. Ooh, cool. Did you do well? 77? Their LCM? A 1.0? I hope that's 1.0 out of 1.0, or I don't know how that grading works. Or is that like 100% at the decimal? Oh, okay. That's like, it's from 1 to 5. So you got the worst score, but no, 1 is the best. Okay. Well, congrats. Yeah, it's like the thing that, like people say that Einstein failed his math class or something. Because he got I think it was actually the exact same, like, grading system. Because he got a 1. Whatever country he was from, that's considered the worst score. Whatever country he was studying in, that was the best score. So he actually like passes math class with flying colors. People were who say that he failed math are wrong. Then an F in English one semester apparently that's short for fantastic. You have supportive parents. All right, let me go put my mug away. Flawless. There you go. Flawless victory. Think it's a Norman EU, however. Well, yeah, Yanis, that's like the quest. You have to go to university in every country in the EU. Hey, Soliman Cabor over on YouTube. How's it going? Form with n can probably be obtained multiplying 3 by 7n plus 1 or something. Yeah, I'll still try to figure out how Jed got there. It might be that. Hey, Dumoed. How are you? Both base answers are somewhat trivial. Oh, with for n? So you get -3 and 2, or 8 and -5. I definitely wouldn't spot 8 and -5 on my own, I guess, but I mean, to be fair, I didn't spot -3 and 2 on my own when I first saw the problem, so increments that decrement them by 7 and 11 accordingly. Oh. It's really that simple. Because you start with -3. If you could subtract off, what multiple of 7 would that be? No, that doesn't work. It must be the other one. 11 and 7. Oh, okay. I was like, yeah, okay, yeah, that actually does work because if you can start with this one and reach this case. If you do, you add -33 to that to get -36, and you would add 21 to get to 23. So that's cool. Should we try 5? I think Pensimer's doing this on his stream, so we have that to fall back on if we get stuck, but if A and B are positive integers, then AB is equal to LCM AB times GCD AB. Some basic math systems to find the first. Oh, that does fit the form of a mod, doesn't it? Oh, that's interesting. You take 7 mod n equals 1. Oh, dude, okay, no, I have to try that. We're not going to 5 yet. Because I want to explore that shit. That's really neat. I said, if I'm thinking about this right, you're saying that, or we can do like 7s mod n equals 1. Right? And 11t mod s mod n equals 1? Maybe, or am I thinking about this wrong? Just say, k1n plus 1 and 11t equals k2n plus 1. No, I mean, I'm getting a little sketched out now. I don't know exactly how this works. Not exactly. Yeah, I don't think this is as helpful as I thought it'd be. I think there's something to something like that. Would you instead rewrite that equation as something as like, okay, I mean, I'd probably just like drop it and move on, but it kind of has to be curious. Like if 1 is equal to 7s plus 11t, could you say that 11t is equal to 7 times negative s plus 1, and that's division? I don't know how you, no, I don't really know how you proceed with that, to be honest. 7s mod 11 is 1. Right, yeah. Because then it doesn't matter what multiple of 11 you're on. So these would both have to simultaneously be true, right? I don't know exactly how you would proceed from there, I guess, but well, like, could you like maybe divide everything through by 7 and say that this solution is only valid when this results in an integer? I don't think that feels a little weird though. Yeah, because the sign it doesn't exactly match. Like I was kind of ignoring that, but yeah, the sign doesn't exactly match what's up there. So I'm not. I feel like there's something here. I don't exactly know what though. I'm going to just like let it be, I guess. So. All right, so if we want to attempt 5, if a and b are positive integers, then ab is equal to LCM times GCD. So, hey, Pegula. That almost looks Greek, but the accent over the A or the dot, maybe that is still Greek, I don't know, but either way, hey. So, for GCD, I assume we're going to use the linear combination property. Do we have anything about LCM? Like, what do we know about the LCM? It is Greek. Okay. Smallest positive integer is the multiple of both a and b. It's not necessarily a times b either, like in this case here. We're doing some we're trying to read along with Penn Center's abstract algebra reading group, and these are the preliminaries that this book is giving for abstract algebra that we're trying to kind of learn and work through, because this is like some property of interest stuff. I would call it number theory, I guess. It's pretty new to me. Like some of this, I have seen a lot of stuff before, but I know almost nothing about it, or like what proof techniques you usually use. So I'm trying to get a little more comfortable with this stuff. So I was I'm gonna try doing this proof here for number 5. I do remember seeing Penn Center do this one on stream. The only thing I remember is he started by dividing the GCD over to AB and working the problem from there, which I might take as my first step too. Because it does seem like you're going to get some kind of useful cancellation if you use our linear combination property, right? Oh god, this window's too thin. There. So let's try this one. Come on. You can erase. I believe in you. Okay. Well, A and B are positive integers, then AB is GCD AB times LCM AB. Okay, so let's just take what Penn Center did as gospel here, which is never a bad bet, and start with this step. And then I imagine we want to write the GCD as a linear combination. We don't know anything about A and B being relatively prime or not, so I think this is generally true. So we can't say that this is going to be equal to anything, which I think is okay. It's equal to some BS, though, I'll tell you that much. That's funny. Oh, it's supposed to be S and T. I mixed them up. I just wanted to write BS. I'm going to keep it as BS, you know? So, okay. What can we do from here? We can... We know that A and B both divide the LCM, right? Could we set okay. That's using the property that the GCD of AB is a linear combination of those two things. Wait, well, okay, let me... I'm pretty sure this is valid, but I guess we'll scroll up and make sure. I'll fix the browser capture in a second. Okay, I found it. Right there. Poppers, yeah, I can help you now, if you want. This is just a for fun question that I'm doing. Yeah, so all I did was I used this property here, Jed. Although I did mix in the S and T, but I think it's more, it's funny if you're at BS rather than as BT. The x-intercept on y equals 2x plus 5. Oh yeah, I can certainly help with that. Good. Set y equals 0 and solve for x. And are you trying to figure out how you isolate x now? Wow, that was bad. One second. I got some butterfingers on me. So you have y equals 2x plus 5. And you want the x-intercept of that. So as you said, let's set y equal to 0 and solve for x. Just make sure you haven't typed anything else in chat. Minus 5 over 2. Okay, perfect. That's the answer that I would get to here. So let me show you how. So if we want to isolate x, we first have to deal with this kind of like plus 5. So let's deal with that by subtracting 5 from each side. So we get negative 5 is equal to 2x, and 5 minus 5 is 0. Now there's only one more step to isolate x, which is dividing each side by 2. So let's do that. Divided by 2, divided by 2. So you end up with minus 5 over 2 is equal to x. And some places are picky, and that's the x-coordinate of your x-intercept. Sometimes they want you to give it as a point, which is minus 5 over 2 comma 0, because it's an x-intercept. We set y equal to 0 and solved for x, so just gotta be careful about the format they might want the answer in. But hey, let me know if those let me know if these make sense. This is like I guess it's like any other problem that you may have done before. We just have just one variable and you solve for it. But it is a different context, which can make it trickier. But it's a normal like kind of procedure where you just subtract off the 5 and then we divide by 2. And even though we get a fraction, it's okay. It's just you get fractions sometimes. That makes sense? Awesome. Glad to hear it. Thank you for the question, Peppers. All right, I'm gonna erase this so I hope you don't need it anymore. And I guess I'll go back to work on this problem that I was just looking at. Okay, so I think my idea next was to say that A divides the LCM of AB, which implies that A times some number K1 is equal to, right? And I think we have to do it for both A and B, but I guess we only need it. I don't know if this is the right move, but let's just try it. Let's see what this gives us. So I noticed that we can divide the A's out here. Can we maybe like try and group the B's together? Does that mean anything? I don't really know. Hey, Felix. A closed form solution to the n body problem? Oh, easy. 3. Because it's a 3 body problem. I don't care which n. No, I don't know. Can this even, like, this doesn't seem, I feel like I made a mistake. Like, this feels like we're gonna force speed to be negative here. Doesn't really feel right. Because B has to be a positive integer, so I definitely did something wrong. S and T could be negative? Oh, you're right, Yanis. So maybe I had something that was technically okay. I don't know if it's helpful for the proof. I mean, is it even... I should be working on one side of the equation here, shouldn't I? I'm making a logical error. I shouldn't be doing anything with the LCM, right? So I'm presupposing that this relationship is already true if I manipulate both sides of the equation. I mean, I guess I already divided by GCD, though. You have a thought, but not sure how to express it mathematically? Okay. I mean, it might help. I don't know. This is tricky one. I'm pretty sure there's some proofs written in Pentanner's Discord that I can look at. But it's usually more instructive to try and puzzle it out for myself first. Consider all the factors of A and B. Dependently not common factors. Okay. Where P and Q are primes. That's fundamental theorem of arithmetic. If they have factors in common, keep one and put it in the GCD pile. Not if we're allowed repeats, Yanis. I'm just repeating how the book phrased it, which was like this. Yeah, Phobos. I know that Penn did it on stream, and I think there's some proofs written in his Discord, but I'm trying to like come to some kind of conclusion on my own, or at least give it a solid attempt before I look at an answer. So, I mean, I do remember that he started by dividing over the GCD and kind of working with that. I don't really remember what happens after, and I was like, well, haven't been able to work it out so far. And then Jed's putting an idea in chat about thinking about the common fact, or not the common factors, but just the factors of A and B. And Jed's kind of making like an algorithm, it seems. Yeah, basically proving that there's nothing in common between the LCM and GCD. Like, I think I understand what you're saying, where I feel like that's kind of the point of the proof, though. Like, we don't know that until we've proven this. This is like a property that would follow from the proof. But you basically like if like you have P1 equals Q1, or like, you know, P1 equals any of the numbers here, you would put them into GCD, and any of the leftovers would go into LCM. The thing is, like, knowing that these exactly will fit into the GCM times the LCD, I think is the point of the proof. So this might be a good starting point. But I don't know if it. I'm not sure. Hey, Brownie Man. Well, yeah, it's like I don't know how you go about showing that these kind of arbitrary primes, that part of them make up the GCD and part of them make up the LCM. Maybe there's a way, but I don't really know how. I think we don't have enough information if we have this approach. But I think you're kind of describing the kind of like algorithm you can use to find the LCM and GCD of a number by listing out their primes and things. Like, we know that it works. We just have like the kind of the question is like proving that. It's like your process you're saying is true. We just need to prove it, and I don't know how you prove it without going at it from like this angle instead. I'm getting a little stuck though. I can't really think of anything to to do with this. Right, Jed? They have common factors. The product of those common factors is the GCD. Right. I'm about to go through and look at what is in Pen Center's Discord. Let me pull it up. You have the algorithm, you just can't state it mathematically. Okay. Oh. Ah, dude, I freaking hate this stupid audio application capture thing. I don't know why it does that. It should be fixed now. Let me know if it's not though, please. I'm gonna look at the solution that Anders posted. Thank you. I guess I just need to do that every time I stream. So it seems like it's happened every time that I stream. But alpha equals AB over G. Since G divides A, right, because it's the GCD, A over G is an integer. And alpha equals B times A over G is also an integer, okay. Which implies that B divides alpha. Oh. So already in basically 2 lines, Anders has gotten to both A and B dividing the same thing, which is a step. If you can prove this alpha thing, you just need to prove that this alpha is basically like the least common multiple now. He's already proven it's a common multiple. Oh, I guess we need the 3rd line too. That would be already implied by this. Maybe not though. Hey Brian, if I can do your math question, sure. And I see a question from Saral Lorik over on YouTube. Give an example in join a topological space is not associative. Come the spaces x, y, z such that x times y times z is not equal. Oh, x times y in parentheses times z is not equal. I have not studied topology, Saral, so I'm sorry about that. I don't know how you would do that. All right, so Anders has proven that alpha is a common multiple of A and B, therefore L divides A, which implies that LG divides alpha times G, which is AB. Oh, okay. Fair enough, yeah. So we've proven that LG divides AB, and I assume now the second part of the proof is going to be LG is the least. Or LG. Oh, is it going to be the. Because these two things are equal to each other. Things that are equal to each other do divide each other, I guess. How are we going to take advantage of this division property, though? Now we divide by the LCM and call it beta. Oh, yeah, sure, Peppers. Let me know. X-intercepts of y equals x squared minus 6x plus 6. Yeah, we can definitely look at that. Yeah, that one is definitely a harder one. Oh, it's kind of a mean one. Okay, we can do it though. Sorrel, love Gojira? Oh, dude, you have good taste. Gojira is awesome. All right, so let's say we have a quadratic Peppers, which are definitely a lot harder to work with. I'm going to erase this. There might be, I think Enigma might have posted an argument like this, Chad, that we can look at after. Because I saw Enigma said something about the prime factorizations. Okay, so you have y equals x squared minus 6x plus 6. And you need the x and y intercepts. So the y-intercept is going to be the easier thing with a parabola like this always. So let's start with that. So the y-intercept is whenever you set x equal to 0. So let's say y is equal to 0 squared minus 6 times 0 plus 6. 0 squared is just 0. 6 times 0 is just 0. So these first two things are just 0. And we're just left with that plus 6. So I'd say our y-intercept is equal to 6. And I hope that you're okay with that much. The x-intercept is going to be a little bit harder, though. So for parabola, you could have 2 x-intercepts, you could have 1 x-intercept, or you could have none. Those are all possible things that you can get with a parabola. It's also called finding the zeros, because we set y equal to 0 here, and we have to solve for x. So this isn't easily factorable. So there's a couple of different ways that this can get taught. The way that I always do it is called, or I've heard it called the AC method, because if you call the coefficient of x squared a, the coefficient of x b, and the constant c, it's basically a process where you have to name something that multiplies to 6 times 1, or just, something that multiplies to 6, and adds to negative 6, and there are no such two numbers. So we have to do the quadratic formula here. That's what the siren's for, Jed, when I'm making a mistake. I mean, I can do a hey, listen also, I guess. And Brownie Man, the GCM and LCD stuff is still for Penn Center's abstract algebra, like reading group. And were you the one who was asking about what abstract algebra actually is before? I realized after that, I could look back at like the foreword, and I think like the foreword of that textbook describes what abstract algebra kind of is better than I could. I could show them graphically too. You've done a mistake when you haven't. I guess that's fair. It shouldn't be that hard for me to add. I just need to not be lazy. I've had a few things sitting on my desktop for like months now that I just haven't got around to adding as alerts. Okay, so yeah, Poppers, as I said, this isn't easily factorable, and if you have a specific way of factoring these, then let me know, because I just don't want to do like a deep dive on something you've never heard of and you're not supposed to use. For this, I'll just use the quadratic formula here, and I'll show what the x and y-intercepts actually mean after we figure this part out. So if we apply the quadratic formula to this, we'd say that x is equal to minus b, which is minus and negative is positive, plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 6, over 2 times a, which is 1. It's an ugly formula, but if you're going to have any formula tattooed on you, it's this one, because you have to use it a lot. I remember a teacher of mine like made that joke, like if you're going to get a math formula tattooed on you, it should be that. And the students started, one of my classmates started joking about like getting it tattooed on their forehead and stuff. And it's like, oh god. 6 squared is 36. 4 times 1 times 6 is like 4 times 6, which is 24. Over 2. So do 6 plus or minus. Square root 36 minus 24 is 12 over 2. You can simplify. Oh, I hope you know how to simplify radicals, because this one does simplify a bit. Quadratic tattooing for it is kind of extreme. I mean, then you have to bring up here to exam day and learn to read backwards. Yeah. You can help out your classmates though. So square root of 12 simplifies a bit. So I know that 12 is equal to 4 times 3, which also means that root 12 is equal to root 4 times 3. And with the properties of square roots, you're allowed to give each of these their own individual square root. And I'm doing this because the square root of 4 is just 2. So we can say the square root of 12 is the same thing as 2 times the square root of 3. So this thing is going to become 6 plus or minus 2 root 3 over 2. And now, since these both have a 2 in the numerator, because 6 is 3 times 2, and you have a 2 just hanging out right there, we can have a cancellation with the 2 down here. So the 2 cancels with that, and with that. The 6 becomes a 3, the 2 becomes a 1. So we get 3 plus or minus root 3. These are our x-intercepts. You can even write it out a bit fancier and say you have 3 plus root 3 and 3 minus root 3. So, Peppers, please let me know if I lost you at any step here. Try the formula backwards. Yeah, that's true. I'll show you what these mean kind of on the graph. Although you might already know what x-intercept and y-intercept mean, so don't let me, or don't mind me if I'm explaining things that you already know. It's my bad. Now, 3 plus root 3 and 3 minus root 3 are kind of annoying to graph. Root 3 is about, like, I don't know, 1.6 or something. Maybe even like 1.7, but either way, I'll go 1, 2, 3, 1, 2. So that's 3. Let's go like 1.5 out. Above, 1.5 out. Below, about. And wherever we hit the x-axis are our x-intercepts. Just make sure I'm not like mixing up my terminology, but because with quadratics, I'm used to calling them the zeros of a parabola, but they're also the x-intercepts. It's two names for the same thing. So yeah, this is wherever we hit the x-axis. The y-intercept is wherever we hit the y-axis. That's only once at 6. 1, 2, 3, 4, 5, 6. So now we can play connect the dots. We know it's a parabola and they look kind of like a bowl. So let's connect the dots with a bowl. So that's kind of like a very rough drawing of what the parabola would look like. But for the sake of your question, you only need that y equals 6 for the y-intercept, and the x-intercept is 3 plus root 3 and 3 minus root 3. And again, you might want to write them in point form, depending on how picky your teacher is. So 6, the y-intercept would be 0, 6. These x-intercepts would be 3 plus root 3, 0, and 3 minus root 3, 0. I don't see anything from you, Pupper, so I'm going to assume that you're okay with that unless I hear otherwise. The thing we have to write backwards is the order of subtraction. Oh, I guess so, yeah, because it's commutative. Wildly complicated to the previous one. Does make sense. Okay, yeah. Parabolas are a lot harder to work with than lines. So whenever you do anything with a parabola, it's usually harder than just a line. But I'm glad it makes sense. I'm on page 47 down here. All right, so let's see if the foreword does explain generally what abstract algebra is. Or the preface. No? Just kind of talking about technique? Never mind, they don't describe what abstract algebra is. I feel like it'd be a helpful thing. Like, just describe what is abstract algebra. Does this book not? Please some of the book answers that question somewhere. No? Okay. Well, maybe it's chapter 1 that describes what is abstract algebra, right? Like, I feel like it's a pretty important question to just leave unaddressed, which I feel like a lot of people it's algebra without the numbers. I guess so, yeah. It's like I mean that's basically my understanding of abstract algebra. I just hate that, like, including like like almost every class that I ever took, they never describe what the thing you're actually learning is. You just start learning things. But I feel like they very rarely give you the kind of like overview. Like, what problems does this field deal with? Not field. Well, okay, I know I can Google it, but why doesn't this textbook on abstract algebra answer the question for me? That's what I... No, not even chapter 1. I guess not explicitly. I don't know. Dihedral groups. I mean, to be fair, I didn't buy it. Oh, I don't... Can I say I didn't buy this? I definitely bought it. Obtuse algebra. Yeah. Is there a glossary? That's a good question. Like, if you buy a textbook on abstract algebra, I feel like it should answer the question, what is abstract algebra? I don't feel like that's unreasonable to expect. Well, yeah, but it's like you have to like learn about algebra before, like I don't know. It's hard for me to express like why. Like, if you're at a bookstore, you read like the back of the book for the summary to figure out if you're gonna like the book or not. Why can't there be like some kind of back of the book summary for a textbook like this? Index of terms A37. I mean, we'll see. I doubt they'll say abstract algebra, but let's just try it. I guess there's a back cover, but let's wait. Index. Let's see if it does. Nope. Got Cayley tables. Yep, these are definitely tables. It checks out. Nah, I don't know. All right. Running Man abstract algebra exists, and that's the best that you get unless you spend like months studying this textbook, I think. Which I feel like it shouldn't have to be like that, but did that cover on Amazon? Oh, maybe. I don't want to show my Amazon on stream, but I'll look it up in a separate window. Because Amazon just kind of says your zip code, and I feel like maybe I shouldn't show my zip code on stream. Contemporary abstract algebra. Joseph Gallion. It was written by a ship. That's not how galleon is spelled for the ship. This isn't the same edition. Oh my god. Okay, I'll read it out loud. What the back? Actually, no. Let's be a bit more fair. Let's look at the newest edition. The newest edition doesn't have the back cover as a photo. Oh my god. What edition is this? 9th edition? All right, let's look for the 9th edition. Yeah, the historical notes are nice too. Contemporary, abstract, algebra, galleon, 9th edition. Because I think the history map is super interesting. Okay, I found the exact one. Where is the back cover? Oh, the back cover's blank on this edition. Oh my god. And I looked at a different edition, and it said, this will provide the reader a solid foundation in abstract algebra, blah, blah, blah. It said something about abstract algebra. It didn't actually say what abstract algebra is. Okay, wait. Okay, this is the Amazon, like, summary. Contemporary Abstract Algebra 9th edition is primarily intended for an abstract algebra course whose main purpose is to enable students to do computations and write proofs. Galleon's text stresses the importance of obtaining a solid introduction to the traditional topics of abstract algebra while at the same time presenting it as a contemporary and very much an active subject to currently being used by work. Yeah, okay, no. That doesn't actually... I don't get why it's hard to give an answer to that question. I have a physical copy of 70. It doesn't offer an explanation. One of our first exercises in analysis to give the multiplication for D6 or D3. Oh, really? And yeah, like, I never learned about the history of math until I took an actual history of math class. And it is really interesting. And I feel like it'd be nice if, or it'd be helpful if, like, you know, those historical notes were peppered in a bit more to, like, normal classes. Because mathematicians they're generally kind of crazy. I feel like maybe you need to be crazy to study math at a certain level. But it makes for, like, interesting stories. Yeah, I feel like this isn't Chris of abstract algebra in particular. Like, I feel like every field of math most fields of math expect you to, like, you know, spend months or years studying what they are, or, you know, studying their problems before you actually learn what they are at a high level. And, like, I don't get why that has to be like that. Like, there's still certain things that, like, I know them by name. I don't really know what all they deal with. Like, graph theory, I at least know that he deals, like, points and, like, arrows connecting those points. That may or may not be, like, bidirectional and stuff, but other than that, it's like, I don't know. I feel like it's easier to explain that abstract algebra isn't. It might be true. I'm not saying it's necessarily easy, I guess, to describe all these things, but I don't know. I'll get off my soapbox. Yeah, so I think you usually ask, like, what's all this GCD and LCM stuff. It's still, like, the preliminaries for abstract algebra. We haven't gone into the real abstract algebra yet. Zach. Rah, rah, rah. How's it going? Thanks so much. Welcome in, everyone. Fenbox, hey, yeah. We don't have anyone in chat asking a math question for now, so I've just been going through this book for Penn Center's reading group. Yeah. Welcome in, everyone. I don't even define what GCD, LCD, and coprime mean in more general settings. Okay. Yeah, so I was just ranting about, like, why can't an abstract algebra textbook, or really a textbook of anything, give a high-level overview of what that thing actually is? Like, we were just looking at the summary of the book and stuff, like, just trying to answer what is the, like, we just wanted to answer the question, what is abstract algebra? Because I have my idea of it, but apparently textbooks just don't really answer that question specifically. And I feel like that is true for many subjects in math, and it probably shouldn't be. You like to get in on that reading group? Lucky for you, you can. Hey, Milk and Horns, if you join Penn Center's Discord, if not already, let me actually just like show it on stream. There. There's this reading group math channel. You might not have access to it. You might need to like DM Penn Center or at him somewhere in Discord and ask to be added to it. But it only just started. Like there's only one session on Sunday, I think. I'm definitely gonna be super behind in it, and I'm just gonna be okay with that. But yeah, all the action's happening over in Penn Center's Discord, basically. Paired algebra is setting the solution sets of different kinds of equations. Okay, that's something. Algebra is linear equations, algebraic geometry is polynomial equations. Okay. Yeah, I mean, I'm more ranting about why the book can't say that rather than trying to get an answer for myself, but that is helpful for me to, like, know, too. Yeah, you can't put your hands on your copy of the Galleon text for some reason, it might be at home. Okay, I mean, in that same chat, there's a PDF of it as well, if you really can't find it. So what we were doing is we were looking at number 5. I attempted on my own, but I got stuck pretty quickly. And I was looking at the solution that Anders posted and trying to understand it. Some big parts of algebra, like a lot of group and field theory. Yeah, that's fair. Because like my kind of how I think of abstract algebra is like you study abstract algebra if you want to go off and create your own type of math with its own rules in a kind of like rigorous way. It provides kind of like a template for you to do that. I don't actually know if that's right because I haven't studied abstract algebra, but that's kind of like how I think of it. But I'd rather like hear an explanation like that from someone that's authoritative. Some kind of prime decomposition trick. Apparently that's possible, Milk. I was looking at what Anders did, which is using divisibility. But Enigma did it a different way that I think uses prime factorizations. Let me actually get that open. Let me just look at it first. Okay. This is what Enigma did here. Hey, Frederick. No, you're given that A and B are positive. The task is to show that A times B is equal to the least common multiple times the greatest common divisor. Oh, and if you're basing it off this part here, showing that certain values or integers are involved in this proof technique here. You know, that's actually what Jed was kind of like trying to do too, although neither of us knew how to bring it to its conclusion, I guess. So there seems to be interesting. We can look at it. We can look at what Enigma did, I guess. They have prime factorizations. Well, it shouldn't be the same end here, shouldn't it? They don't necessarily have the same number of primes. A third approach, you're looking for more variations? Ooh, I mean, it doesn't hurt. This end thing, it might be like a tiny bit wrong, maybe it doesn't actually matter? Swimming dog or cat? I like both, but I'm more of a cat person. It's not really unless it involves moving a deficient quantity from one side of the equation to the other side. All right. GCD is the product of the common prime factors of A and B. Like, I know that that's true. Do we have the foundation to prove that that's true? I don't know, let's go with it. I guess, okay, Enigma kind of explains it more here. Okay. That's fair enough then. So we can define GCD as some subset of the prime factorization of A, which is also equal to some subset of the prime factorization of B, which aren't necessarily the same in length. I think. And we can define this kind of like partial product as P sub I and Q sub I. Okay, so, okay, this really is what Jed was thinking. I thought this would be too much of a leap, but I guess you could justify it. As some scalar times the rest of the partial product, I guess, like, you know, whatever you didn't include in your GCD. Yeah, Enigma kind of said that he skipped over some of the little stuff, and it definitely seems like he did, which, I mean, is fair. I mean, it's like this is like a homework where you have to write out every last thing. All right, so that's an interesting argument. I mean, I can't say it doesn't work, I guess. I don't know if I understand every last like part of it, but it's interesting to show that angle. So back to going to GCD and the ones I use go into the LCM. Yeah. Let's see what Phobos posted. Let a and b be positive integers. Let m be the LCM and d be the GCD. And GCD will also break into the linear combination with x1 and x2. Consider dm over b. I was about to say that was g, but no, that's b. So that's basically dividing each side of the initial thing. I mean, without saying it, we're dividing each side of this equation by b, and we're considering the LCM times GCD over b part. We split that up into two different fractions, okay? And then we group it, the b's cancel, okay? Which is divisible by a. How do we know this is divisible by a? Because m is the LCM of AB. So each of these does have an A factor in it. It's just a little bit hidden behind the M. Okay. Fair enough. Phobos, yeah? So that means A divides this first thing that we started with. Okay. DMO over B. Really, so if you have the B in the denominator here, you can really bring it over to say AB divides DM. That makes like algebraic sense. I'm just trying to like, or I mean, that makes sense in how I'm thinking. I just don't know if I'm thinking about it in the right way, so I'm trying to like justify it. Get to multiply both sides by B. Yes, like that's what I was thinking. I was just like, I was just wondering if that was the correct way to think about it, I guess. If A divides DM over B, seems it's not strictly true. Okay. It's like you can't generally do that multiplying each side by B trick. Frederick, I thought I answered that. It's a one-way. Oh, okay. Oh, you're using that. Okay, okay. So yeah, that makes perfect sense. I didn't make... I was mentioning the same B being transferred over here, but no, you're multiplying each side by B, which I guess is really the same thing, but... So I was thinking about it the wrong way. Frederick, I answered the question. Can you not hear me? Okay, so AB over D, I assume just considering this in a vacuum, AB over D is equal to A times B over D equal to B times A over D. Hey, Ben. Common multiple of A and B. AB over D is a common multiple of A and B. I guess so, yeah. D divides B, D divides A, because D is the GCD. Okay, good. I was wondering like how we know that these are integers still. Since AB divides DM, AB is less than or equal to DM. So AB over D is less than or equal to M because we're multiplying each side by 1 over D. Is that allowed when you're, well, I guess we're dividing by D, but that's really, okay. I'm just wondering if like 1 over D isn't an integer, but it's fine because you get cancellations. Unless D is 1, I guess, but. Since M is the least common multiple, what's happening in this second to last sentence here? Since M is the least common multiple, AB over D is equal to M. It can't be smaller than the smallest. Right, if we're given that M is the LCM, then there can't be anything between AB over D and M. Do we know that means equality? AB divides DM. I still can't really figure out how you get from here to here. Less than or equal to just equal. It can be less. Why can't it be less? Well, M is the least common multiple of AB, but when it's AB over D, doesn't that change things? Right, like I'm okay with like going from this to that, but I thought that like, you know, You only know anything. M is the LCM of A and B, but how do I know how M compares to AB over D? Did we establish that before and I'm forgetting it? I don't know, maybe I'm just being slow. It's not the first time that's happened. AB over D is a common multiple of A and B. Right? Oh. That's what I'm missing. AB over D is a common multiple of A and B. I just need to, I guess, reread this, like, middle sentence there. As the smallest possible. Oh, okay. I am being slow. Okay, I missed the significance of this sentence here when I first read it. Okay. So, like, when I read it, I was like, why do we need this? But we needed it because of the, like, literally the sentence immediately after it. I need to be better about giving out saves. So let me, give you a save for that, Phobos. Thank you for both posting the proof and explaining it to me. God, but this one, it really is a doozy, isn't it? I think I still actually need to look through the second half of Anders' proof. But I kind of just want to get a different problem, so I'm getting, like... I think I'm beating a dead horse with number 5 now. Like, I just want, like, a little, like, refresher for my brain, a different problem to think about. But actually, before that, let me, is there really no audio on YouTube, or is Frederick just doing a troll? No? I'm coming through on YouTube. Okay. What other problem did Penn suggest to do? Oh, 5 wasn't even on the... Oh, 5 was on the list for Sunday stream. I'm confused with what's Friday and what's Sunday, but let's just do 6. I see it's on the list in there somewhere, so... Oops, that's not what I meant to do. So, what is 6 saying? Suppose A and B are integers that divide the integer C. If A and B are relatively prime, show AB divides C. Isn't this Euclid's lemma? Was this left as a proof for the reader? Or am I forgetting what Euclid's lemma is? Right, Fembox. If P is a prime, then divides AB. There we go. Okay, that's how it's different. P divides A or P divides B. So is it? It feels like Euclid's lemma is related, but maybe I'll have to use it in some way. Suppose A and B are integers that divide the integer C. If A and B are relatively prime, show that AB divides C. And so, oh, you're doing the show by example part, Fembox. Show by example if A and B are not relatively prime. 6 divides 12 and 4 divides 12, but 24 does not divide 12. Right. Skip the hard part and did the easy part? Yeah. When I was reading the question, I was like, oh, well, we should start with the show by example part. It's much quicker. And so I think kind of the hint in there is because they have that factor of 2 in common, you know, their GCD isn't 1, things get thrown off. Ugh. Okay, I assume we're gonna have to do some kind of substitution here. Let's play around with this. I do remember Pen Center doing this one on stream as well, so we can have the VOD to fall back on. Worst case. Come on. I know you'll erase eventually. Okay, let's do red. Okay, so finally did 5. Oh, if you want to post your solution, Yanis, I'm happy to take a, or I would definitely like take a look at it, but it's up to you. Okay, so I need to see the problem again. I can't see my own little like corner of the stream where I have it posted for you guys. You want to type up it anyways? Okay, no worries. Do you ever rotate your board to distribute the wear? I cannot say I've ever done that. That's probably a good idea. This thing, I assume it just slides off the end and I can just flip it. Yeah, I should probably do that, Phobos. Good idea. To be fair, it is just like a 20. I bought it for like $25 off Craigslist. Frederick, I don't really care how many subs I have. I don't like looking at that stuff on stream, especially. Emster, hey, you emailed your teacher about the problem you sent on Tuesday. Turns out it was a typo in the question. Oh, thank you so much, Emster. I was like, yeah, your question seems so hard, like needlessly hard. So I'm glad it was a typo when you weren't actually expected to like do something that bad. So we have A and B are integers that divide C. A and B are integers. A divides C. I guess I should say A, B, and C. And B divides C. Show that if they're relatively prime, implies that AB divides C. Okay. That's the problem. Okay. So, I mean, immediately I want to do our linear combination stuff. And if A divides C and B divides C, we could say that C is equal to some constant times A, and C is also equal to some other constant times B. I kind of want to say then that A equals C over K1 and B equals C over K2 and plug it in up here. That's kind of what I was thinking when I first saw the problem, at least. I don't know if that really leads us to anything special, to be fair. But let's just see. And then what can we do with this? What would if we plugged it in one at a time and got two different equations for C with involving A and B? Maybe that's a thing? Because I don't know what you do with what I just wrote. Like, what if we took this and we solved it for C, maybe? We don't know that... I don't know if these are integers or not. I feel like I'm never doing the right thing with this. I'm going to be honest. I feel like I'm already off on the wrong track. I don't really know what this means. Hey, Anders. 10 watch streak. Wow, thank you. I was just looking at your proof for the problem before this involving AB equals GCD times LCM. And I thought it was pretty nice. I still need to go through the second like half of it though, but I feel like I could, now that I see the idea that you were using, I might be able to like figure it out for myself at some point. So I was just attempting number 6, the one right after it, and I'm probably already on the wrong foot here. For problem 5, yeah. Right up there. Yeah, for this one, I feel like this probably isn't right. We want to get to AB divides C. Could we add these two equations together? Because I did just notice that it would look like a linear combination that's equal to 1. We don't necessarily know that that exact K1 and K2 are the linear combination, though. Can we know that? I don't know. Just add them together for fun and see what happens. It's like it'd be a mistake to say this is equal to 1 right now without some kind of like justification. Do you remember sharing your solution problem 6? Start from the LCM and try to make C appear into that. Because we start with the LCM. Gonna make C appear into that. Okay. What? LC linear combination? Oh, okay. So I thought, sorry, I thought that was a typo. Okay. So yeah, I mean, I guess that's where I was going. I mean, we don't have to restrict ourselves to like doing some kind of sub with C. We could we could even multiply through by C if we wanted. So I feel like we need to do something probably fancy, like multiplying through by AB or something. Start with linear combination, try to make C appear into that. I think that's what I was trying. Wait, the other two I just erased are helpful? Oh, dang it. All right, let me rewrite it. A divides B implies that, no, A does not divide B. A and B are relatively prime, what am I going to say? A divides C implies that C is equal to some constant times A. A divide, I just did the same thing again. B divides C implies that C is equal to some other constant times B. So what I did, I solved that for A and B. And then I plugged them in one at a time. Rather than at the same time. Maybe you do want to plug them both at the same time. I don't know. Oh. Well, yeah, do you just use the fact that we proved number 5? If AB is equal to GCD times LCM, we know the GCD is 1. Um, I think you use like something from here down with this, wouldn't you? I don't know. That's not starting with a linear combination. I guess I don't know. Applying 5 is also good in your book, Anders. I I feel like it's a good idea. I don't know. A times B is the least common multiple of A and B. How do we? I guess someone need to relate. Well, there's a C right there, and there's a C there. So you know our proof is done, right? QED. AB is equal to some multiple of C. It's equal to L times M times C. There we go. Done. C is common multiple of A and B. Well, oh, can we just sub for one of them and leave the other one alone? Like A, if we say B is C over K2, I guess, using my thing from above. The LCM, it's some multiple of A or some multiple of B, right? Am I going to say K3 just to make my work even messier? Like K3 times A? No, 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 no. Or do we want to sub them both? Oh my god, I combined a B and a comma there. I don't get how my brain works, dude. And like, do we get C squared is a multiple? I feel like this would imply, well, I don't know. It's C squared. That's why I was trying to avoid doing the double sub. Hey, why do we? I was. Oh yeah, you're over in Gold's chat. Um, you're right. This is the preliminaries that a book is using before you actually get to study the real abstract algebra, and I'm trying to work through those preliminaries. I need to remember the definition of LCM that's useful to prove things with. Let's just like look at it, because I did look at it at the start of the stream, but evidently I'm not remembering it. Wait. It's like the ultimate is not that like as convenient like linear combination form, which is why I kind of struggled to work with it in proofs, like the GCD does. Multiple of both numbers, right? And it's the smallest one? You do sub them both? Or you do multiply through by C zone? Oh my gosh. For the strategy that I was trying to do before? Okay. Well, that's actually a nice proof too, but... LCM of AB divides N. Okay, I mean, I want to know both these techniques. Or like these strategies. One involving applying 5, the other doing basically what Zone Ranger said. And I think Anders was hinting at that I got stuck on. I'll keep 5 on the screen too. Ah. I don't know, this last line still seems like, or these last 2 lines still seem like garbage to me, but... Get rid of those 2. So you multiply that through by C, and then you just strategically sub to get what you want. So over here, there's already an A here, so when we unsub the C, we're going to use our B. K2BAS plus, and in this C, there's already a B, so let's strategically use the A. K1ABT equals C. Then you just rearrange it to get K2TAB plus K1TAB equals C, and look at that. See, as a linear combination of AB, which actually, well, sorry, no. Just group the, or factor out the AB entirely. That's what you want. You don't want the linear combination. So we're not worried about the GCD. You want AB as a multiple of that. K2B plus K1A. So that's just an integer times AB is equal to C. Okay, so that's like, now that I know what you do, that's a pretty simple way of showing it. I'm still weirded out by this LCM thing. I think maybe I need to be more careful about what's subbing. K2S, not K2. Oh, oops, yeah. K1T. You think you're proving to solve Promianus? Oh no. Okay. I must be doing something wrong there, right? Do I want to use like could I multiply this through by C, I guess? I don't know, maybe I'm a... How would we make this strategy work? And like, do we write the LCM as, let's just say... I'm just gonna make my work super messy and say K3 times A. And then it'd just be... Well, no, we don't know anything about... No, I don't think that's right either. Include AB divides C, and you check the sum multiplies AB is an integer. Oh, really? I missed. Oh, well, I thought that being an integer would be a given. Or, I thought that'd be reasonable enough to just say. Okay, and you're saying we don't have to multiply by C for the second one. It's like, I know that we can write the LCM as something times A or something times B. I don't know, how do we do that in a way that's helpful? Anything about like a boatload of saves once I sit back down. LCM is a multiple of C? LCM don't... The LCM is a multiple of C. Because if A divides C and B divides C, that's still... I don't know how you use that. I'm going to be honest. Oh, you use that property that every common multiple of A and B is a multiple of the LCM. Okay. So wait, since these are common multiple of A and B, so how would we, since A divides C and B divides C, C is a common multiple of AB, and like, what is that called? That, do you have to prove that somewhere else in this, or are we given that somewhere in the chapter? By the definition of the LCM? Oh, okay, okay. Oh, wait. This statement isn't quite right, though. Is this just the point in the proof? Okay, I feel like I kind of get the idea. I feel like this isn't the right way to phrase it, though. C is a... I feel like I just cut to the chase and I shouldn't have. There should be like something between here. But I can't really figure out the right words to say, to be honest. Okay, before I forget, save for Zone Ranger, saves for Femvox, saves for Anders. Yeah, we didn't miss anyone? Oh, yes, I don't know if I actually read your idea. My idea was that given G divides AB, which means there exists some GL equals AB, right? You can show that L is the LCM, but you can't get it to work. Oh, okay. Okay, well, I mean, I feel like I completely understand the first proof. The second proof, I have a hard time kind of phrasing, but I think it works. I just am terrible with number theory proofs and actually phrasing them properly. Oh, it's exercise 10 to prove that every multiple of A and B is a multiple of LCM. So maybe it's actually not good to use this before we've proven it? I don't know. Depends on the order you do things. You have a messy proof of problem 6. It takes a couple of leaps. Okay. I'm a fan of leaps. I don't know if it was asking me in a spot to put it in that reading group thing. And I'm sure it's still welcome just in that general like text chat, but you could also put it in my Discord too if you wanted. I don't care either way. That's kind of a good question, Phobos. I don't want to like mess the Penn Center has, but I would think that it would belong just in that general like reading group thing. Just like, oh, it's my solution for number 6 or something. I don't know. I don't think it matters either way. Oh yeah, or yeah, the DMing is completely fine because I'm not actually sure like for myself, so because I feel bad if I had it like in my Discord, I guess, because then I'm like taking discussion away from Penn Center. But like I think this is fine. You're just like DMing me. A divides C and B divides C. GCD of AB equals 1, right? B divides C means C equals BY for a suitable integer y, right? And A divides C means... Is there a typo here? Oh no, okay, if B divides C and A divides C, then A divides YB. Okay, so AX equals YB. Okay, that's fair. No, that's all good. I'm not known for my clean proofs. If A equals 1, then AB equals 6. Oh no, AB equals B. Oops. And B divides C means AB divides C. Yeah. Okay. If A is greater than 1, then suppose... Is that AXY? AB, oh, AB does not, okay, I was wondering why it's almost like a chi or something. I was thinking, okay, I bet, no. Then A does not suppose A does not divide Y. Okay. Then the GCD of A and Y is less than A. Right, because it can't be greater than A, and it certainly can't be A if A does not divide Y. Okay. So Y times the GCD of AY is less than AY. It's a consequence of this. Basically multiplying each side by Y. Your proof isn't even salvageable? Oh no. So we try to show that LCM, dang. And AY is equal to the G. Ooh, AY is equal to the GCD of AY. Oh wait, times. Oh, I missed the second part of that. I was like, AY is not the GCD of AY necessarily. But no, times the LCM, that's completely fair. So Y is less than the LCM of AY. Oh, okay. Using this part is less than this part and dividing the GCD out. Okay. Which is a contradiction, right? Because you can't have Y is less than the least common multiple of something in that thing. So A divides Y. Okay. And this is helpful because C is equal to BY, so we're going to be able to get an A in here. Okay. And so we accomplish that by taking this, dividing each side by A, which, okay. Y over A times B. We know Y over A is an integer. B is an integer. So B divides C over A. And then you multiply each side by A. Huh, interesting. So I was thinking that if we know A divides Y, you would say Y equals, maybe Z times A, and then just plug it in up here. And you get C equals B times AZ. But I don't see what's wrong with this either. Can you tell me a synonym of not fake? Like real? Basically where that's the opposite of fake. So authentic, real, genuine, yeah. Hey Dan. Danny Thesaurus Highway. Danny the Thesaurus Highway. There we go. Real can be misinterpreted. Authentic or genuine. Yeah. I mean, or I'm stupid, but assuming we have some L prime less than L, such that K1 is equal to L prime, and BK2 is equal to L prime. So say GCD would be L prime over K1, K2, and it's wrong. Oh god. Yeah, I mean, this is me, Yanis, you're barking up the wrong tree. I'm struggling with these number theory proofs. You're doing a proof by contradiction to show that L is, or whatever you got is the LCM. Donaldson not fake, because he's a real G. Searching for the fake coin problem? Oh, cool. I also wrote it wrong, but you'll try something different? Alright, fair enough, Yanis. Dude, that coin problem is it you only get 3 ways. I don't know how you possibly do it in only 3. But Phobos gets another save for that nice proof. Did I already give out saves for the rest of this? I think I did. Okay. You think you have the trick, you don't have time to implement it yet. Okay. You did a math. You did indeed do a math. Should we just keep going and go for 7? If a and b are integers and n is a positive integer, prove that a mod n is equal to b mod n if and only if n divides a minus b. Ooh. My first thing to say this is easy, and that's a mistake. I'm sure once I actually write things out, it's going to be a lot harder. Let's see if we can figure it out. Because like it's like, don't you just like subtract one over, and then you take the mod of each side, and then you have something nice? But I feel like I guess with all these proofs so far, it's like I can look at them and I know that they're probably true. I just don't know how to actually show it. Because I've never really done number 3 proofs quite like this. Okay. Let's do green. Okay. So we want to show a and b are integers, n is positive. A mod n is equal to b. Oops. Mod n if and only if n divides a minus b. So I think I want to start with like going from here to here first. Because I feel like maybe there's some kind of manipulation that we can do. So if a mod n is equal to b mod n, like can we subtract b mod n over here? So just numbers. It's equal to 0. And then I want to take the mod n of each side again. And ooh, that's, well, maybe that's okay to do. I don't know. Mon? Come on, Mon. Mod n. What is 0 mod n? I was hoping it's just 0. Actually, no. It's n. No? Yes. It's n? And that's what we want? No, I don't actually know. It means 0 mod n means that 0 is equal to some number times n plus a remainder r. So it's like if you just had like 2. Is it 0 and 2? So you always get n back? 0 mod n is 0? Oh no. Oh yeah, no, if s is 0, then yeah, you have 0. So I don't know if this is good, but we can yeah, I guess if you do 0 divided by a number, you never do have a remainder, do you? So, I mean, but maybe that's a good thing. I honestly don't know where this is going. So, this is also what my mind went to at first. And so this is the same as a minus, I get that right, a minus b mod n is equal to 0. Oh, wait. That's what we want, though, right? Wait, does this mean AB divides N or N divides AB? It means that A minus B is equal to some multiple. Aha! Kn. Okay, cool. I think we're good for the first direction, and I did that. Without help, which is nice. Well, I mean, okay, no, I'm sorry. I actually did have help from Phobos on the 0 mod n bit. So let me actually, before I forget, let's do that save. Hey, Richard Cuttingware. Yeah, these are the preliminaries for this abstract algebra textbook that we're going through with Penn Center. Prove operations, distribute. Oh, dang it. I don't know how else you would do this. I mean, they showed this like technique when they're teaching you about mod in general. Is there a different way that, I mean, A mod n is equal to B mod n. I mean, we can try and look for a different way of doing it. If A mod n is equal to B mod n, A mod n, let's do our K1, K2 thing. Wait. A mod n implies, well, I mean, it doesn't imply anything, it's just a number, but we can use an arrow here. A mod n, if we're doing A mod n, it means that, well, plus R. We don't know about divisibility yet, do we? Oh, I don't know if that really helps. Okay, I don't know how you do it if you don't do it the way that I did. Okay, well maybe I got ahead of myself with using properties of mod. But at least checks out with properties later on. I don't know how you would prove it if you're not allowed to do this, like I guess going from this line to this line. And I assume you're allowed to take the mod of each side too and not, I guess both these lines are a little bit, like, you know, going from this line all the way down to this line is a little bit sketchy, but potentially. Another one? Okay. Yeah, before I move on to the other direction, let's look at what you did. Get the extra tabs. Suppose R equals A mod n equals B mod n, right? Because they're both just numbers. There exists Q1, Q2 such that A mod n is equal to Q1n plus R. It starts to cut off? No! It's doing it again? Oh my god, this freaking thing. It's just I've had people like tell me that it's done that multiple times in one stream. That's even more annoying. Hopefully that fixes it. Okay. No, I'm kind of curious if it's going to happen. Oh, wait. I don't know if it's going to... Where does my Firefox audio get sent? Okay, I'm kind of curious if this is going to happen if I play audio through Firefox instead. Synthwave music. I don't know. Synthwave radio. Just do that. Okay. So I wonder if it's the same thing's going to happen if I do it through a different application. Oh, how loud is it going to be? And we'll keep it there. I feel like it's going to be too loud. A mod n Q1n plus R. Do we know these are the same R? In that it's... Well, okay, yeah, we know it's the remainder. Oh, okay, yeah. Okay, fair enough. Then you subtract... You do A minus B. Ooh, don't mind this. So how do we know that A minus B is this thing? So we know A mod n is Q1n plus R. But we kind of chop off the mods in this next step. It seems like it, at least. Well, I guess it, yeah, okay, no, that's... I think it's just A is equal to Q1n plus R. Yeah, and B is equal to Q2n plus R. And then this first part makes sense to me, I think. Okay, that's a nice way of doing it. It's probably less sketchy than my way. And before I look at this other direction, let me try it for myself. So if we, if n divides A minus B, then do we have A mod n is B mod n? I'm betting we do, but... and can we... I almost want to reverse the steps of your proof. Some number q times a minus b. Can you do like a plus r minus r thing? Let me do it in a second step. Well, ooh. Oh, yeah, no, actually, no. Does this get us anywhere? I don't know if we can quite do the reverse. I think we get stuck here. A minus b equals qn. Oh, wait, did I play this in reverse? Oh my god, you're right, Fembox. Yeah, you're right. Yeah, if n divides ab, then it's ab is some multiple of n. Thank you. Okay, well, what happens here? I feel like doing a minus b is a one-directional thing, and we can't go back in the other direction, so this isn't going to work. But just for the sake of investigation, let's like confirm that, I guess. So like what will we have? Like a plus r equals q. That's not what I meant to write. Yeah, I don't really know. Yeah, so it probably, you can't just reverse the steps that simply. You get a proof? Oh god, all right. So would we want to take the mod n of each side, or like how do we want to proceed with this? Like, what happens if we do take the mod n of each side? A multiple of n mod n is 0, right? And so that would let us reverse the proof that I did up here, assuming it is reversible. I think it would be reversible. I don't see why not. I don't know, but again, like that proof that I did is kind of sketchy, so. Yeah, I don't know how else you do it, so maybe we should look at Phobos's second part. That's what you're thinking too? Okay. What did Phobos do, though? Oh wait, isn't this the wrong thing? Isn't the same mistake that I made? If n divides AB, yeah, it should be something times n equals AB, I think. I'm beginning. Wait, n divides AB. I mean, now I'm beginning to doubt my knowledge of n divides AB, A minus B. T divides S, which means T times something equals S. So if n divides A minus B, it's n times something. Oh yeah, so I think it is the same mistake, or I think it is the constant goes over here. But can the proof like be salvaged with that? Give you the right conclusion? Yeah, that's fair. Once you're looking at cases, I'm kind of curious. Do they provide answers like it's number 7, right? Which is an odd number. Is there an answer in the back of the book? Sorry, I'm kind of all over the place right now, but oh well, okay. Oh, for number 5, the book does it Enigma's way. And then for number 7, this seems like your idea, Phobos. Wow, if n divides A minus B, the uniqueness of the remainder, we have R1 equals R2 equals, or R1 minus R2 equals 0. The cat's being fussy, so you're in and out. Oh, no worries, Phobos. That's the entire proof for the second direction. By the uniqueness of the remainder. R1 minus R2 equals 0. Oh. I think maybe... Let's try investigating this a little more, because I think this is just like their very brief summary, like version of the proof. If n divides A minus B... Hey, Hardlocked. I didn't use K. Yeah, I think you still have. I mean, you said. I think your idea is so much like the book's idea, so it's probably fine. Like the uniqueness of the remainder R1 minus R2 equals 0. Like, okay, let's just examine in a vacuum A mod n. It means that A is equal to some number times n plus a remainder R1. B mod n implies B is equal to some other number times n plus another remainder. So if you subtract these two, K1n plus R1 minus K2n plus R2. A minus B is equal to K1 minus K2n plus R1 minus R2. And since AB divides, or since n divides AB, since n divides A minus B, R1 minus R2 equals 0, which implies R1 equals R2. Which implies that the mods are equal. Okay, I like that. That's nice. You can't read Russian. Can you rewrite it in English? Okay, you know what? I'll read in perfect English. You know, like English has like the backwards R and the weird like LB. That's one letter, even though it's two different things, and they have like the backwards N also. That's a W, but don't worry about it. Perfect English right there. It's not Russian. Okay. So I definitely like that technique for that direction. What do they do for the first direction? So I'm a bit less hyped on the thing that I did. Okay, so for this one, we're just going to consider in a vacuum A equals the meaning of A mod n, Q1n plus R1, B equals Q2n plus R2. And then we're going to subtract the 2, I guess. And since their mod n's are equal, or since mod n they're equal to each other, we already know from that stage that R1 equals R2 because their mods are equal. Oh, okay, and that kind of does the rest of it. So we know that A minus B is Q1 minus Q2 times n, and that's just an integer times an integer. So yeah, that implies right there that n divides AB. Okay. A minus B. I keep saying AB, but same thing, you know? Okay, that's nice. Let's not scroll the entire thing. Oh, Yanis, you posted your answer to number 5? We can see what's up with this. For natural number AB, define G as the GCD of AB and L as the LCM of AB. We have GL equals AB. Well, we want to, okay, yeah, and then you're proving it down here. We'll show AB over L is the greatest common divisor. First observe that AB over L divides A. Ooh, okay. L over B is an integer because L is a multiple of B. Right, L over B is an integer. Okay. So yeah, okay. So AB over L, I can buy that divides A. And the same thing works for AB over L dividing B, meaning AB over L is a common divisor. Assuming G prime is a bigger common divisor, let G prime be greater than AB over L, G prime divides A and G prime divides B, which means, right, G prime times a constant is A and G prime times another constant is B, multiplying them yields G prime squared, K1, K2 is equal to AB. You divide one of the G primes over, that's fine because G prime divides both A and B. That L is greater than AB over G prime. Just a contradiction. Why is L greater than AB over G prime? Oh, we're rearranging this inequality up here. Okay. L is the smallest common multiple. Oh, okay, so you show that AB over G prime is a multiple of A and B, a common one. But if you arrange this equality, you get that this AB over G prime would be smaller than L, which it can't be because L is the smallest common multiple. Okay. I guess that's fair. I did get caught up, but the proof the book favored was going to the prime factorizations of A and B. I guess I should go back and like follow it better, but it seems like there's a lot of ways to potentially prove this. Hmm. Well, nicely done. I don't see an issue in that, at least. So I guess coming from me probably doesn't mean a lot. Hmm. I'm kind of debating what I want to do with the rest of the stream. Uh, I'm getting a little bit like mathed out, I guess. I kind of want to do some chess because I've been kind of hyped on chess because candidates is coming up. I don't even do chess for like super long, but it'd be kind of fun to play a little bit. I do need to take a bathroom break too, though. Hmm. Almost done typing the coin problem? Oh, okay. In that case, I'll stay on math for a bit, and I will to take a bathroom break, and if you happen to be done by the time I'm back, if it's convincing to me, yeah, sure. I'll take a bathroom break, and then I'll come back and look at your solution. I'll put it in my BRB screen. Let me I'll pause that. Get back through Spotify and just hope it doesn't pause a bunch. BRB. Okay. You might still be typing out, Andrew. So in the meantime, I guess we'll take a look at another problem. What's up with number 8? Let D be the GCD of AB. A is equal to dA prime and B is equal to dB prime. Show the GCD of A prime D prime is equal to 1. Interesting. Whoa. I think this is simple. Famous last words. Because I think this will follow pretty directly from the linear combination. And doing some subs. D is equal to GCD of A and B. And A is equal to dA prime. And B is equal to dB prime. Then GCD of A prime, B prime. I think you're right. This is simple. Okay. Let's take some food quick. Oh, okay. You upload the PDF since it's almost a full page. Oh, okay. This is just taking like one thing to do this proof, I think. Because writing the GCD as a linear combination equal to D, make that work clearly in D. Then let's do the subs that were provided here. So A is equal to dA prime times S, and B is equal to dB prime times T is equal to D. Now we divide everything through by D, and I think we have our answer. So I think that's sufficient. A prime, B prime is 1. Hey, Promament, how's it going? I'm glad that there's at least one proof that came kind of easily. I guess that other one with the mods came easily. I just don't know if it's right. This one I'm pretty confident in, though. Let's check out the solution that Andrew's posted to the coin problem. Come on. Oh, did you have a different way, Phobos? Took a leap, maybe unfounded. I'm curious how else you would do that if you do have it handy to send, but no worries if not. Okay, so this problem is completely separate from anything we've been talking about. This is like I've been seeing this going around on the internet that you have 11 coins. One of those coins is either lighter or heavier than all the other coins. If you only get to do 3 like weighings, how can you determine what the odd coin out is? I believe is what the problem, like that's what the problem is. And so this is the solution that Anders came up with. Some of the coins from potion results in general. Oh, really, Yanis? Let's number the coins from 1 to 11. Also, named the left plate is L and the right plate is R. All right. So we put coins 1 to 4 on plate L, which will say L of 1, 2, 3, 4. Okay. Fake coin and determine if it's heavier. Oh, I don't know that. It might be. How many weights are, or how many ways are needed to find K fake coins given N coins? Wow, I don't know how you do that. I, I don't know if Anders. I see that here. There's the heavier coin is the fake. I'm not sure if this the solution determines whether it's heavier or lighter. I'm not sure. How many times am I gonna say I'm not sure? I guess let's read through it and see. Coins 5 to 8 on plate R, and we'll say that's R 5, 6, 7, 8. So if these two wings are equal, then we can discard all the coins on those plates. Oh, is part of the problem to determine whether that odd coin out is heavier or lighter, or just that it is different, and you don't care if it's heavier or lighter? Oh, I see. Zach said nice, and there's one case you didn't write that seems symmetric to another one. Okay. And okay, before I dive deep into this, let's look at Phobos's solution for 8, because it seems pretty quick. Because it's going to be like a page read. In either case, the argument discover which coin is different. Okay. Oh, yeah, you probably tell that without too much trouble if you're isolating it anyway. GCD. Oh, is this like a contradiction? I assume it's more than one? Should that be a double prime? Or... Wait, if they're GCD... Okay. It's equal to DXA double prime. So, okay, taking the GCD of DA prime and DB prime and then subbing the double primes in. Oh, factoring a D out of the GCD, or the DX out? I feel like that might be okay. I'm not sure though. If you can factor things out of a GCD like that. Dx is greater than D is equal to the GCD. Oh, so you find that GCD of AB is greater than GCD of AB. X is greater than 1. Huh. Yeah, I mean, if that stuff there holds up, I guess it's good. That's just, I agree with the though. Interesting. Um, all right, so I guess let's dive into this coin business. Discard all the coins on the plates. Okay, so if the first 8 are balanced, yeah, there's no such situation where being the first 8 there. Can replace any coin in the plates for one coin that was not used in the previous step. Okay. So we're taking out 1 and we're putting in 9, everything else being the same. And if they're not equal, then 9 is just the odd one out. If they are equal, then the third attempt, we take out 9, we put in 10, then that would imply 10 is fake. As long as the first weight turns out to be balanced. Okay. That's fair. And yeah, if 10 turns out to be... Yeah, and from this you would know whether the odd coin out is more than or less than. So yeah. First case should be easy to fix. We have 3 sets of coins. You have 2 weighings. Just weigh 9 versus 10 as your second trial and then go from there. Oh, was there an issue with this first case? Oh, just for knowing whether it's heavier or lighter. And Fembox, you're saying to weigh just 9 versus 10 as a second trial and go from there. So if they're equal, then you know it's 11. You compare them with any other coin, and you know if it's heavier or lighter. If they're not equal, you could get screwed there because you don't know which one of those is fake. Or like, yeah, I don't know. If you do just 9 versus 10, you don't know between 9 versus 10 which is the fake one. If you choose wrong, you would have no information on whether the... Well, no, you would. You can refer back to whatever was happened before. Okay, yeah. I think you can deal with that then. $10, you're right. The geometry's problem? It is pretty elegant. All right, so now we have the third case, which is if 1, 2, 3, 4 is bigger than 5, 6, 7, 8. The fake coin in the set of coins we use 9, 10, 11 are authentic. Oh, that's what you were asking. Yeah, authentic is a nice word. Can I choose a problem of 13 coins? Really? Is that what the Polish student found? Still only need 3 ways? Wow. Second way, let's compare 3, 4, 5, and 1, 2, 10. 3, 4, 5, and 1, 2, 10. Really? So 10 we know is authentic. I guess let's see what this is going to tell us. If they're equal, then we can discard them all. Interesting that we're throwing in a coin that we know is authentic in here. That is, we know 1, 2, 3, 4, 5, 9, 10, 11 are not fake. Yeah. Fake has been 6, 7, 8. We compare 6 versus 7. If they're equal, then we know the 8th coin is fake. We don't know. 8 has never. No, we know from the first one that 8 must be lighter because it was on the right side and it was less than. But if 6 is greater than 7, we know coin 8 is not fake. The fake coin weighs less than the others, so coin 7 is fake. Oh, that's clever. So yeah, this has so far been getting that whether it is heavier or lighter. You just have to remember back to like your first weighing, potentially. Oh, and so you were saying you didn't do the opposite case where it's less than, but it's symmetric, so it shouldn't be a big deal. And so now, oh, so I see what you're saying about having a lot of subcases, I guess. So we dealt with the case where where the second weighing is equal. But there's 2 other cases, so let's look at the greater than case. Can we already know, say 5 is not fake? Certain. Moved it from, we moved 5 over here. Oh God. That's hard for me to follow. We know 10 is authentic. If 5 is heavier, we would have gotten the flipped result here. And we didn't. It couldn't be true. If you flip this inequality, this couldn't be true with that at the same time. No. I think your wording is like it's fine. It's just that's a complicated problem. Okay. Coins 1 and 2 can't be fake. Yeah, okay, it's still hard for me to follow, but I think it makes sense. It's when everything gets swapped, it's like it's just kind of complicated. So if you only swapped 5, I can definitely see it. But when like you swap 5 and 1 and 2, I guess maybe it gets harder for me to judge. The scale is still inclined in the same direction. The link didn't work and you can't speak Polish, but that's the guy? Oh, okay. I'm even going to try to pronounce that. Literally 5 consonants in a row at the end of his last name. So we know that 1, 2, 3, 4 is greater than 5, 6, 7, 8. I'm still trying to work this 1 and 2 and 5 being genuine thing out. So the scales are still the same from one wing to the next, even though we changed things. Okay, this part is hurting my brain. I'm just gonna accept it as fact because I still can't make this work in my head. um, but the first way we knew coin 10 was not fake. Therefore, the fake has to be heavier than the others. It's either 3 or 4. So yeah, if I say this is true, I can definitely see how 3 and 4. Uh, the heavier one is the fake coin is heavier, so you just do 3 versus 4 directly. And the heavier one is the fake one. Okay. Uh, Finally, if you get the less than case for your second wing, okay, can I swing among the coins and move to the other side? God, the main thing tripped me up is we were going from 4 coins on our first wing down to 3 coins. I'm like, to the opposite side. Oh, yeah. I mean, other side is it also works, I guess. Opposite may have been like a little bit better, but And again, I'm just going to take this as a fact. I still can't wrap my head around it. In this case, 3 and 4 are real. 10 was automatically real. So it must be 1 or 2. No, just the whole, like, when you switch coins thing, we're confirming that, like, 3 and 4 are real, or in the last one that 5 is real and 1 and 2 are real. It's just hard for me to understand those bits, because there's just so many things happening between those two weighings that, like, it's just hard for me to follow, I guess, and work out in my head, like, what exactly is happening. Measure 1 and 2. If they're equal, then 5 is fake and it's lighter. If 1 is not equal to R2, and we know 3, 4, 5 are real. Ah, the heavier coin is a fake coin. Fair enough. That's a nice, like, proof. Assuming, I guess the only part that I can't really knowledgeably that I remember like following is that one like bit, but everything else I feel like I'm good with. Suppose we only have 6 coins. Okay. First weight is 1, 2 versus 3, 4. Okay. Five and 6 are real coins, right? While you do that, I'm gonna put my hoodie on. Oops. Oh wait, I need to take my mic off. 1 second. Don't know why my hair is so messy, but at least my headphones kind of cover it. um, switch some coins to the opposite side. Let's say we choose 2, 3 versus 4, 5. They're equal or remove the fake coin, right? But if it's... Wait, but now the left is less than the right, so it's switched sides. Should that inequality be flipped? Okay, okay. Okay, so 5 we know is legitimate. So it must be that either 4 is lighter or 3 is heavier? Okay. I think I'm following that. And so if we go to the harder case, 3 can't be heavier because of the first weight. Oh, right. So, sorry, yes, that means 2 is heavier or 4 is lighter. Okay. So from our first weighing up here, we know 1, 2, 3, 4 is heavier, or 4, 5, 6, 7, 8 is lighter. And then when we shift things around, if we get the points of the same plate are real. I guess so, yeah. But if, so, okay, if we now do 3, 4, 5, it's greater than 1, 2, 10. Then it must be that 3 or 4 are the heavier ones. Okay. And if we get the opposite, that 3, 4, 5 is less than 1, 2, 10, then it must be that 5... Wait. Either... that either 1 and 2 are heavier, or 5 is lighter. Wait, that's not the point. That's the exact point. It has to be either 3 or 4. Oh, I mean, okay. To me, that's like the indirect way of thinking about it. The more direct way is just to skip straight to what must be the odd coin out. Because to me, it's like I would try to figure out which one is the wrong, like what set of coins are potentially wrong, and then by default, all the others are authentic. To me, it's just a difference of how we think. Sorry, yeah. what I was saying out loud makes sense to me at least. It might not be right, but it's at least how I was like thinking about it. But like thinking like, you know, 1, 2, 3, 4 are potentially allowed to be heavy, or 5, 6, 7, 8 are allowed to be potentially light. And then you add in this other information here. I guess that's easier for my brain to track at least. So 3 and 4 are potentially allowed to be heavy. You basically, like, you know, they're not lighter. And so over here, if you're more suspicious of them being lighter. Wait, no. God damn it. The more I explain my own... 1, 2, 3, 4 are allowed to potentially be heavier. There we go. I got to reverse. There we go. And so if they were heavier, this couldn't be true. So that they must be real. 5 can still be heavier, or 1 and 2 can still be heavier. But yeah, 3 and 4 are definitely real because we can't have this and this. Okay. Yeah, I mean, thinking about it in terms of switching things around, it was kind of confusing, but like, from this weighing here, like 1, 2, 3, and 4 can never be a lighter coin, and 5, 6, 7, 8 can never be a heavier coin. I guess I'm just thinking about in terms of like eliminating possibilities. And then if you add in like this information, 1 and 2 wait, I said 1 and 2 cannot be the lighter coin. And over here, they can't be the heavier coin. So they're forced to be the real coin. And 5 cannot be the heavier coin. And over here, it looks like it would be a heavier coin, but we already know that it can't be, so it must be a real coin. Okay. I think I follow this. I definitely can't see the faults. Yeah, what's up, critical thinking? It's a good time for a question too. I think we're just... I feel like I understand this, and nice job on the Santos guy. I wouldn't have gotten this. You have to really go back and remember your first like weighing and like use that information. You have y equals 2x plus 1 to the 5th, or times x cubed minus x plus 1 to the 4th. Are you taking the derivative of that? Yeah, I would absolutely use product rule. The alternative is multiplying everything out and doing the power rule, and that sounds terrible. So I definitely would do product rule on that. For example, in the other direction, then we'll have basically the same case and procedures. I'm willing to accept that as true. I'm not willing to actually write it out and prove it, but I don't see what would be different. So as you said, it's like a symmetric, I would think. Do you want to actually see the problem written out? Critical, because I'd be happy to actually show you. Or if all you want to know is to do product rule, then I would say yes. I would absolutely do product rule. You want to see it? Okay, sure. I just don't want to spoil it if you didn't want to know the answer. Yeah, like the inequalities will go the other way, but you know the answer? Okay. Well, it's going to be the product rule, and in applying the product rule, we will have to use the exponent rule and the chain rule. So the product rule gets taught, well, it really only gets taught in one way. I usually just do a shortcut with the product. Like, I don't bother showing my work with the product rule, and I just skip right to the end result. But just to kind of show how things are going to work, I'll actually show my work. Because it is a little bit of a complicated product rule to apply. So we have y equals 2x plus 1 to the 5th times x cubed minus x plus 1 to the 4th. Okay, just make sure that I copy things down right. So the showing the work that I'm referring to is actually kind of writing out like f and g and what f prime and g prime are. So if we're going to do the product rule, I'm going to call this f. Oh my god, I can't write. And that g. So f is 2x plus 1 to the 5th, and f prime is, this is a much simpler derivative to do here. So we'll just do the power rule, bring the power down. 2x plus 1 now to the 4th. And then chain rule, we have to multiply the derivative of the inside, so times 2. So we get 10 times 2x plus 1 to the 4th. Do the same thing over here with g. X cubed minus x plus 1 to the 4th. G prime will do the same exact procedure, bring the 4 down. The inside stays the same. Cubed. Now we have to do the chain rule here. Derivative of the inside, 3x squared minus 1. Which I'd probably just leave that as it is. Now we know the product rule is f g prime plus f prime g. So let me actually write that out. Y prime is f g prime plus f prime g. So f we said is that, 2x plus 1 to the 5th. G prime we said is that. I will write the 3x squared minus 1 first, just because I like doing things by order of exponent there on the outside. I should have gone on to a new line. I'll come down here. Hopefully the writing isn't like too bad. So now we have plus f prime. To x plus 1 to the 4th times just g. So technically you could stop here and this is your answer. But you might be able to get a little bit of simplification if we do some factoring. Yeah, I'm still planning to do chess. And if you want to do some chess variants, or if you want to play, I'm definitely down. Yeah, it's definitely more hard than or it's definitely more annoying than hard. Do you have to factor it? Yeah, so we're gonna do some you don't technically have to, but it sounds like you have to for your class. Let's do some factoring. So we have a 2x plus 1 to the 5th, a 2x plus 1 to the 4th. So we have a 2x plus 1 to the 4th in common, so let's factor that out. 2x plus 1 to the 4th. They have an x cubed minus x plus 1 cubed, and an x cubed minus x plus 1 to the 4th, so they have a cubed in common, so let's take that out too. Cubed. Technically, we have a 4 and a 10, so we can take a 2 out just for fun. I don't think that one really matters as much, though. All right, so now what are we left with? What are we left over with? We have a 2. We only took out 4 of these 2x plus 1s, so we still have another one left over here. All of these has gone away because we took out 3 of them, and we have 3 out here. So that 10 we took a 2 out of, so we're going to do plus 5. We took out all 4 of those 2x plus 1s. We only took 3 of the x cubed minus x plus 1s out, so we still have 1 more left over there. And now we're just going to work on the inside of these parentheses and group like terms, and then I think we're really done. So we get a 5x cubed. I'm kind of rearranging terms in their by their power. We get a 4x minus 5x, which is minus x. Get a 2 plus 5 is 7. So I think this is just our final answer here. Let me know if that matches, though. I mean, I know nothing about chess variance standards, but I know that you like them. So if you have any that you wanted to play, I'm down to try them. The sum of 1 over 2 to the n plus n converges if n goes to infinity. Is that like a homework question, or that's like a challenge question, Richard? I'm happy to try and think about it either way. It just kind of informs how much time I want to spend on it, though. Both? Okay. I think you could maybe compare it with 1 over 2 to the n, which is greater than, and it converges. So actually, I might know how to do it. Oh, you found a fen box? Nice. Well, Herman textbook answer is 2x plus 1 to the 4th, x cubed minus x plus 1 cubed. What? How did I mess up the last part? How do you possibly get a 17 in there? Did I copy the problem down wrong? I have a plus 7. $17x cubed. Like, that means there would be a mistake pretty... Oh... Wait. No, never mind. Wait, oh my god, I dropped the 3x squared minus 1, I think. 3x squared minus 1, 3x squared minus 1. It disappeared in this step. So yeah, for some reason I thought that got factored out also, but it certainly did not. The 3x squared minus 1 doesn't factor at all, so it's still annoyingly attached here. It's going to be 6x. Is that going to get us 17 though? 12. It will, because the other one was 5x cubed. Okay. I think I'll be right now. Okay. This should be good. is working inside the parentheses here. So yeah, I just dropped that 3x squared minus 1. It's my bad. I'm going to multiply this out. 12x cubed. Okay, let me do this procedurally. 2x times 3x squared is 12x cubed. 2x is minus 2x times 2 again is 4x. One times 3x squared is 3x squared, times 2 is plus 6x squared. Negative 1 times 2 is negative 2. Okay, plus 5x cubed minus 5x plus 5. X cubed minus x plus 1 cubed. So we get 12 plus 5 is 17. X cubed, 6x squared is just 6x squared. Minus 4x minus 5x is minus 9x. Minus 2 plus 5 is 3. I hope that's right. I don't remember what the answer was. 17x cubed plus 6x squared minus 9x plus 3. Bam! Look at that. Okay. Brandyman, the question is just taking the derivative of y at the top of the board there. No problem, critical. And Richard, yeah, I think we can do a comparison test on that. You have the sum. We don't know necessarily the starting index, but it shouldn't be that important. 1 over 2 to the n plus n. Converge or diverge. I still say n equals 0 because n equals 0 does work. And I think you would make the claim that 1 over 2 to the n plus n is less than the sum 1 over 2 to the n, because it's a smaller denominator, which means a bigger overall number. And that's just a geometric series with a rate less than 1. 2 to the n converges, which implies 1 over 2 to the n plus n converges by comparison test. I think that's all you need for that one. No problem, Richard. Oy. Yeah, okay. I was just like verifying it in my head, and I'm pretty sure I'm good. Okay, so unless anything else from chat, I might switch over to chess now. I don't think I'm going to do it for super long, but I'm going to do a little bit of it. Oh, it's not good me playing chess. I don't see anyone else who's doing math who's on right now. I think Dan will be going later. But yeah, if you're looking for math, I know I'm going to recommend you all too. Yes, Anders, I remember I saw Admiral Stapler playing it. It looks like fun. WeChess, yeah, I normally play on WeChess. I also have a chess.com account. Do you want to try drawback chess, Anders? I don't know how to set. I think it was its own like website. Yeah, let me shoot. I do want to go and take my whiteboard down quick. Actually, let me change my scene entirely. One second here. Okay. Dropbackchest.com. Okay. Do you draw your own pieces? All your pieces have beards on them? No, so this is it's something I think I rated Admiral Stapler while he was playing this. It's chess, but you have some kind of like downside, like some kind of special rule that you have to follow. And they get kind of wacky. And you don't know what, like, you and your opponent have separate drawbacks, and you don't know what the other's is. Okay. Almost ready, Anders. Let me go, I guess we can do this scene, can't we? Is that the worst thing in the world? Chat probably has to be moved, doesn't it? Maybe we'll put it up there. Okay. Oh, I mean, I believe that you would be honest about it, Anders, just at looking at the drawback. Cheat? Yeah. So, I mean, I'm okay with just not hiding it if you don't mind, like, not looking at that screen peeking. How do we do this? Send a link to a friend. I guess we should do a time limit. I don't do you have preference on any of this stuff? We could do like 5 + 5 or something, right? I mean, maybe even like, do you want to do like 10 + 5? As you like. Okay, I guess let's start with like 10 + 5. So this might be the hand. Oh my god. Oh, okay. You can actually choose. I guess I'll leave all this as default, and then the color is random. Computer time looks off from the server? Copy link. Better to have some time? Yeah. You can always adjust it. Let me find you in my DMs. There you are. Ready? Are you in? Okay. You mute also? Okay, sounds good. Make the whole board. I mean, it's just on the left side, unfortunately. I can move everything else. Yeah, that's a good point, Dan. I didn't realize that it was in such a weird spot. I don't know why everything's just on the left. Okay. Dude, this drawback. Let's start. So Andrew's muted, so I guess I can talk freely. You can't move your rooks. If you lose your rooks, you lose. You love it. I shouldn't get too wacky with my opening. Surf? I'm not gonna surf today, Ben. I'm sorry. This is, I don't know. Just gonna try and play normally, I guess. Tomorrow? I mean, maybe like tonight off stream if we'll be around in like an hour or two. But surf's up. Okay, can I even castle here? Maybe I should put my bishop over there. So yeah, I don't, Anderson hasn't done anything particularly weird yet that would maybe like know what it's, it seems really helpful if you can figure out what your opponent's rule is. I can castle at least. That doesn't count. I guess it counts as the king move. Really? Okay. He hasn't pushed a pawn by 2. That could just be a playstyle thing. He hasn't castled either. I think we can push this pawn. Oh, you know, maybe I should be going for some wing pawn action if I can't move that rook anyway. Okay, so what's happening here? And if I push, like he could bring his knight there. Wait, should I have been able to go after that? Should I push that pawn? If I take, what happens? I mean, I could just not react also. Actually, let's take the knight, I think. Because now if I retake, his pawns are going to be messed the hell up. Oh my god. If you took my queen isn't really the queen. I guess the knight defends the queen, but these rooks do not defend the queen. I really don't want to trade off the queens. So maybe let's bring the queen out here. So my rooks are not real pieces right now. So I'm putting a lot of pressure on his knight, but I feel like just importantly, I'm putting pressure on that pawn over there. I guess this queen move might keep everything covered. But I could maybe... I think casting counts as a king move, Fembox. I'm not completely clear on that either, to be honest. I could take there... If bishop takes, then this is like a really good move. But Anna's probably smart enough to do queen takes, in which case... Man. I feel like it's going towards trading off all the pieces, and I feel like that's terrible for me. Because my rooks are so useless. If I can clear out like that one pawn, I could try and go for the A push. This dark square bishop really doesn't have anything else to do. I can't, like, I want to bring my knight here. What if I did that pawn push? Wish you could have taken a push. Because if he takes there, then I win the knight. Or I guess I win the bishop. If he goes queen back or queen there, then I can take that pawn. Okay, I think this is a good move. Not every time I've said that and then realized that it's a blunder, but... Oh wait, I never changed my category. And the YouTube stream is still